Hi students, we are ready for 3.2, which is synthetic division. In your at-home notes, you would have gotten the division algorithm written down. It says, let f of x and g of x be polynomials with g of x of lesser degree than f of x and g of x of degree 1 or more. There exist unique polynomials, q of x and r of x, such that f of x can be written as the product of g of x times q of x plus an r of x. Now, r of x is either going to be 0, so in other words, it won't have a remainder, or the degree of r of x is going to be less than the degree of g of x. Now, to avoid errors, we're going to use 0 as a coefficient for any missing terms, including a missing constant when setting up the division. In other words, if I were to divide something like x cubed minus 2x, then we would set up the synthetic division where we have a 1 for the coefficient of x cubed, a 0 for the coefficient of x squared, a negative 2, don't forget the sign that's sitting out front, it goes with that coefficient, the coefficient of x, and a 0 for our constant. We don't have a plain number term there. And this would be how you set up your synthetic division. More about that in a bit. Now, it's important to note, and this was in your at-home notes, synthetic division can only be used if the divisor is of the form x minus c. That means the x that you're dividing by, it has to be a plain x. No coefficient in front of it, except for the 1, and no exponent on that x. It's a plain x minus c. If it's anything other than something of that form, then you're going to have to fall back on long division and divide your problem that way. Let's go ahead and get into a synthetic division problem. We're going to divide this polynomial by this polynomial. Go ahead and set up your your synthetic division table. The coefficients are 1, 2, negative 17, negative 10. Be careful, get in a habit of checking to see if you have any of those missing terms. We don't on this one. Now we're dividing by x plus 5. What you'll want to do is think of this being set equal to 0 and solve it. So our value we're going to set out front is negative 5. That's the number that we're going to be pushing through this synthetic division process. Now, here we go. We're going to carry down the 1. 1 times negative 5 is negative 5. And 2 plus a negative 5 is negative 3. That's one full cycle of this. You're just multiplying up and combining down. So negative 3 times negative 5 is 15. Combined is negative 2. Multiply up is a positive 10. Combined down is a 0. That is the process. So now we're going to go ahead and write this x cubed plus 2x squared minus 17x minus 10 is equal to the x plus 5 that we divided out times the quotient of x squared minus 3x minus 2. So you have started the factoring process. Really, if you look at this, it's quite extraordinary what you've done. You've partially factored a polynomial that you wouldn't have been able to do with intermediate algebra skills. Now, you cannot factor this by grouping, which is what we would normally factor something with if it is 4 terms. So this is a new method of being able to factor something, and it's really what most of Chapter 3 is about. Okay, the special case of the division algorithm says for any polynomial f of x and any complex number k, there exists a unique polynomial q of x and number r such that the following holds. F of x is x minus k times the q of x plus the r. And that's where we came up last time, that this was 0 on our problem. Our remainder was 0. Okay, let's just get into some more synthetic division. We're going to write our answer in this form. Okay, again, I'm going to set up the synthetic division bar. I've got 1, 3, 2, 2, 3, 1. I didn't have any negatives and I didn't have any missing terms, so make sure that you're checking that every time. And we're going to put a -2 in front. And we start with a 1 just because we have to have something to start with. Multiply up and combine down all the way through. So 1 times -2 is -2. Combine down is 1. 1 times -2 is -2. Combine down is 0. 0 times -2 is 0. Combine down is 2. 2 times -2 is -4. Combine down is -1. -1 times -2 is 2. Combine down is 3. So we're going to write our polynomial f of x, which is the numerator up here, as our x minus k, x minus -2. So x plus 2 times the quotient. Now what is this going to be? Right here is going to be our coefficients for our quotient, and this is the coefficient for remainder. The quotient, how do you know what power this is going to be? You can start from the very end and go counting up. This is a constant, an x squared, an x cubed, an x to the 4th. Okay, so you know that that is a 1, x to the 4th, and so on. But also, if you think about this, we're taking a 5th degree polynomial and dividing it by a 1st degree polynomial. It makes sense that we should have a x to the 4th polynomial as the quotient. So either way, that helps you to remember that. You've got a couple of ways there. I have x to the 4th. The next thing is a 1, so I have a plus x cubed. I have no x squared, so you don't have to put a plus 0x squared. And for here we have a plus 2x and a -1 constant. And we're adding in the remainder of 3. Okay, again, let's try this one. Now you've done this one before. You may not remember it, but you might find this pretty neat when we're finished with it. We have a lot of missing terms here, and we have a negative, so be careful with writing this out. We have a 1. We have a 0x squared. We have a 0x, and we have a -8. Okay, so 2 missing terms here. And I'm going to put a 2 in the front. Carry down the 1 so you have something to start with. 1 times 2 is 2. 0 and 2 is 2. 2 times 2 is 4. 0 and 4 is 4. 2 times 4 is 8. -8 and 8 is 0. So apparently x minus 2 divides x cubed minus 8 evenly. There are no remainders, so we can write this x cubed minus 8 as x minus 2 times, or x cubed divided by x is going to be an x squared, 1x squared, plus 2x plus 4. All right. Now, does this look familiar to you? we kind of just said before when we were learning how to factor this, just kind of remember the pattern, and then you can be able to factor something like this. And this is a difference of cubes. Remember our process before that we told you just to kind of get the pattern and know that it works is to take the cube root of that, put it there, the cube root of that, put it there, and then we take this and square it, put it here, take this and square it and put it here, and then multiply these things together and put it here. And then you use SOAP. Right? Well, now you don't have to just take it on faith that it's just a pattern that you memorize. We can see, not just with multiplying and see that you end up with a difference of cubes when you multiply these special polynomials together, but you can see with synthetic division that it really does work. You have a remainder of 0, so that x minus 2 goes into x cubed minus 8 evenly, and you see what the quotient is. Pretty neat. You try it with the sum of cubes as well. It works. All right, let's try something like this. Just make sure that you get enough practice. If you want to pause the video and try it on your own, and then resume the video to see if our answers match, that's a good idea, good strategy. Carry down the 2 so you have something to start with. 2 times 1/2 is 1, 3 and 1 is 4. Half of 4 is 2, and that's 0. 0 times 1/2 is 0, 1 and 0 is 1. So we do have a remainder here, and there's our quotient. So the proper way to write this would be 2x cubed plus 3x squared minus 2x plus 1 is equal to a 2x squared plus 4x, you don't need to put the plus 0, and multiply that by the x minus 1/2, which is your divisor, and then you're adding in your remainder. All right, looking good. Let me scooch this down a bit so it's not in the way of that process there. Looks pretty good. Okay, again, if you want to pause the video and set this up yourself to see how you can do it on your own, and then check back by resuming the video, go ahead and do that. 1. Also, you might want to just pause as we go through this. I will make these videos as short as I can by going through these problems at a good pace and knowing that you guys can pause it as you need to think about something or write something down. 1 times 5 is 5. Combined down is 0. 0 times 5 is 0. Combined down is -2. -2 times 5 is -10. Combined down is 0. So again, I know that my x cubed minus 5x squared minus 2x plus 10 is equal to x minus 5 times x squared, there are no x's, and a minus 2, and no remainder. So this goes in evenly. All right, you're going to find that you have a lot of theorems in Chapter 3, a lot of information tidbits, and we're going to probably want to organize that. Maybe make a separate sheet of these theorems, or even note cards where you're putting the name of the theorem and the theorem on one side, and then on the back side, maybe write out what it means in your own words, and an example problem worked out where this is used. I won't be asking you to spit out these theorems word for word, but what I will do is have you to have a working knowledge of them. So if something says that you're going to use the remainder theorem for something, probably need to know what that remainder theorem says so that you can be sure that you are demonstrating your knowledge of that theorem. The remainder theorem says if the polynomial f of x is divided by x minus k, then the remainder is equal to f of k. Okay, so we've already done several of these. Let's go ahead and look back at those. We've got a polynomial, and it's being divided by this x minus k, and then the remainder is equal to f of k. All right, well, if our polynomial is this f of x, let's just use it for this last example that we did. F of x equals x cubed minus 5x squared minus 2x plus 10. Okay, can you identify what your k is? For this problem up here, okay, so we're using this problem down here. K is 5. That number there is your k. If this said x plus 5, then it would be an x minus negative 5, to put it into x minus k form, and negative 5 would be your k. But here we have a k of positive 5. Now, how do you normally get an f of k value? Normally you just plug that into the x, right? So let's do it the old way. Okay. We get 5 cubed minus 5 times 5 squared minus 2 times 5 plus 10. 125 minus 5 times 125. Oops, sorry. 5 times 25 minus 10 plus 10. A little more room. I get 125 minus 125 minus 10 plus 10 is 0. Okay, let's read through the theorem again. It says if the polynomial f of x is divided by x minus k, which is what we did here, then the remainder, this guy here, is equal. It's equal to taking f of k. Those are the same. This process up here was so much quicker than this, you know, and it's not all about being quickest or the easiest, but it is an elegant way to do it, just to do synthetic division, which gives you a less opportunity for mistakes. And this will serve some other purposes for us as well as we go on. So just trust me, you're going to want to know that this fact, the remainder is equal to f of k. That means go up to the previous problems. If this was your f of x and I found f of 1/2, then I would get a 1 out at the end. That would be very messy to do here with all the exponents and the fraction going on. Synthetic division makes you happy. It's a lot easier. This one, if f of x was your x cubed minus 8, and you put in your 2, okay, then you're going to get a 0 remainder. That one's easy to tell because you only have one thing that you have to plug it into and then simplify, and so on. It really does work. It's true. Okay, we're going to use the remainder theorem here to find f of k. So this is not unlike something that you would see on an exam. You are expected to understand what the remainder theorem says and how to use that to find f of k. You'll be showing your work for me on your exams and uploading that for me to grade. So when I'm coming to a problem like this, if I've asked you to use the remainder theorem, I need to see evidence that you use the remainder theorem and you know what it means. Okay, so we're going to divide f of x by the k and in synthetic division, right? So 2, -3, -5, 4, being careful to watch for negatives and there are no missing terms. Now they outright gave you a 2 here. You don't have to figure out what k is. They tell you k is 2. We'll start our synthetic division. 2, 4, 1, 2, -3, -6, -2. So this remainder, the remainder theorem says, is f of 2. So we'll write that out. By the remainder theorem, you know, that is naughty. I had a professor at the university who would not let us write theorems in lowercase letters. By the remainder theorem, f of 2 is -2. F of k equals the remainder. All right, if you want, go ahead and try these before I do them. Pause the video, see how you do. We're going to use synthetic division again because the remainder theorem talks about the remainder after you divide. 6, -31, -15, and I have a -1/2. I have a 0 constant. Okay, let me make sure and put that in there. 6, -3, -34, 17, 2, -1, -1. And we say, by the remainder theorem, f of -1/2 equals -1. Okay, again, try this one. We've got 1, -1, 3, and this is interesting. We're dividing by a 3 minus 2i. Right. Might want to give yourself a little room here. All right, so I've got 1. 1 times 3 minus 2i is 3 minus 2i. And then I'm combining down, so that makes that a 2 minus 2. And now you kind of have to squish that little I in there. But now continue, we're multiplying up. So you're taking 2 minus 2i, multiplying it by 3 minus 2i. Remember, going to have to FOIL that all out. Double distribution. So I have 6, -4i, -6i, and a +4i squared. So this becomes a -10i. This becomes a -4 plus your 6 is 2. So this times this is 2 minus 10i. And then I have to combine down, so I get a 5 minus 10i. So by the time you're finished adding all that up, we can say that by the remainder theorem, f of 3 minus 2i is equal to 5 minus 10i, that remainder there. Give yourself enough room to squish those I terms in there. Give yourself enough room to do your extra work. And you might want to put a box around your answer when you're finished so you can separate that from all the work you did to get your answer. All right. Potential zeros of polynomial functions. A zero of a polynomial function, f of x, is a number k such that f of k equals 0. So that's all that is. It's a number that if we put it into the function, it equals 0. Now, by the remainder theorem, we also know that if your remainder is 0, that means that f of k is 0, which would mean that k is a 0. That remainder theorem is a quick way to decide whether a number k is a 0 of a polynomial function f of x. All right, so we're going to use synthetic division to find f of k. If the remainder is 0, then f of k equals 0, and k is a 0 of that polynomial. If the remainder is not 0, then k is simply not a 0 of f of x. So these words are synonymous here. A 0 of f of x, it's a root or a solution of the equation f of x equals 0. All right, we are going to use synthetic division here to decide whether the number k that is given is a 0 of the polynomial function. If it's not, then give the value f of k. So we'll set up our synthetic division. Be careful of missing terms and negatives. K is given as -5. Carry down the 1 and start your process. Multiply up, combine down. Multiply up, combine down. So we are going to say that f of -5 is 0, and further we are going to need to state that -5 is a 0 of f of x. Here, go ahead and set up your synthetic division. 2, 9, -16, 12, and k is given as 1. Again, check negative signs, missing terms. We're good, we're ready to go. Carry down the 2 and start that process. Multiply up, combine down. Multiply up, combine down. Multiply up and combine down. Here, f of 1 is 7, so you can further state 7 is not a 0 of f of x, just to be certain, to show that you have done that and you understand it. That's it. Go ahead and do your homework set and then get your study guide together with these problems that I've listed in my labs for you. And let me know if you have any questions. Don't hesitate to schedule a one-on-one virtual appointment with me. I'm here to help you through the rest of the semester. And have a good day.